Okay, guys, welcome. The session is being recorded, everyone. So if anyone would like to revisit this particular demo, they can go over it again. The session is being recorded. Guys, so this is Roshan. I'll be leading you through this demo and the course that we have planned, Cloud Performance Engineering in DevOps and Site Reliability Engineer. So for the timing, those who are joining now, I have requested all of you to just help me with your technical background and the years of experience. Use the chat option uh, to just mark your answers. I have got a lot of responses, and to sum it up, what I think most of the folks here are from the performance testing and engineering background. There are a few folks from QA engineer background as well, but and there are a few from non-IT, and one is fresher. That's fine, but mostly I would say that we have performance testing and engineering background here that people have joined. Okay, so guys, welcome first of all. And this particular course, we are here on the demo of the cloud performance engineering and site reliability engineer. Both are like a hot cake in the market, and both are, you must be hearing these about these two. Uh, I would say the job profile quite often nowadays from last couple of years. Uh, you would like those who are working on the performance testing or QA background, you know that in any interview you are being asked questions on the cloud performance engineering. They are expecting you to know container technology. You're expected to know Kubernetes technology. You're expected to know CI/CD pipeline and automation, a lot of cell scripting. Apart from the core performance testing work that you do, the performance testing, you could use any performance testing tool like Jmeter or LoadRunner or NeoLoad or Locust or any other tool, right? Or you do performance engineering activities like troubleshooting your applications. Could be thread contention, could be memory issue, could be database issue, SQL query being slow, or could be configuration issues at the application server or the DB server, or you would be working in that. But from last couple of years, the trend is that most of the solution, most of the infrastructure are in cloud, and the companies are looking for people, those who have the cloud experience, and that too in containerization, right? In the container technology concept like Docker and Kubernetes, right? Guys, do you guys agree with me on this part? Can I get yes or no idea? Just these three options. Can you guys help me with your responses? Use the chat option again, guys. So I do see yes responses. Megha, SB, Akshay, Mohan, Kavya. A lot people are saying yes. Seshu, right? Everyone is talking about these technologies nowadays, right? So yes, absolutely, guys. So this is the trend, right? And we are in, and these two skill sets that we're talking about here, the performance engineering and the site reliability engineer, is not that much difference, but we have a differentiation factor as well. We'll talk about it, how these two domains are different, the job profiles are different, and how they are different. We'll talk about it. It is not actually different. Okay, so let me get started first, guys. So just a brief about me. Those who are meeting me for the first time, I'm having around 15 years of experience, more than 15 years experience in IT. Started my career into development, Java development, and then I went into Python development, into automation as well, using shell scripting, Ansible, Python, uh, Terraform. I have been involved into multiple things. I'm currently working as a principal SRE. I do a consulting work with one of the reputed giants, and as part of my passion, I do like to share my knowledge. So here we are meeting, right? And I have been a performance engineer quite some time. 6 years I was completely into performance engineering, Java performance engineering, looking into the code optimization, while working into data structure and algorithm, right? So I was involved into that. From but last 6 to 7 years of my career, I'm completely into DevOps and SRE. So I would not say the performance engineering. I'm not working on performance engineering. Performance engineering is a skill set that you require, everyone at the higher level, right? You require. So it's all about troubleshooting application, making your way out, and things like that. So So site reliability engineer, being principal site reliability engineer, and my past experience with performance engineering is quite helpful in my current role that I am pursuing right now. Okay, so this is going to be the agenda of the session, guys. We'll start with a question, right? And I would like everyone to answer on that part, and then we'll talk about the software development, normal stuff that is there, software development and deployment evolution, how software was developed and deployed over the period of time. We'll talk about that, uh, and we'll talk about the course syllabus. We'll set the expectation what you're going to get from this training, right? And you can ask me any question. Looking at the number of crowd people have joined, I would not encourage right now to have a like to speak anyone to speak in between unless you have a very important question. But end of the day, be rest assured that I'm going to unmute all of you and I'm going to clear everyone's doubt. Okay? Just be rest assured on that part. Okay, and we'll talk about what will I learn by the end of this course, and we'll talk about it. Okay, so guys, let's start with the question. I would like everyone to just comment, right? Do you guys think a performance engineer or QA engineer? Okay, I do see few folks QA engineer have joined, or DevOps engineer. Like let's keep it generic, right? Developer, QA engineer, DevOps, performance engineer. I'm talking about in generic skill sets here. Do you think that we need to know these things, looking at the current market trend, that Akshay Jhavar is saying my voice is breaking. Guys, is my voice breaking?
No, it's perfectly fine.
Perfect, thank you. Yeah, Akshay, please check the connectivity from your end and use the earphone. Okay, thank you, those who confirmed. Guys, so I would like you to comment here. Do you guys agree with me that as a performance engineer or QA engineer or a DevOps engineer or a developer, we need to know these technologies as per the current market trend? DevOps, microservices, containers, cloud. I'm just talking about these four things. Someone saying absolutely. I think Gayatri mentioned absolutely. Yes, Gayatri saying absolutely yes. And a lot of people are saying yes. I would like everyone to engage with me on this so that you guys are active, right? So yes, absolutely, guys, no doubt about it, right? I have been talking about this from quite some time, and yes, it is absolutely must skill sets for anyone in IT. I would say I would generalize these things for anyone in IT. If you are a developer or a QA engineer or a DevOps engineer or a performance engineer, performance tester, or a support engineer, whoever you are, you need to, if you really want to do well at what you are doing, being in any position in IT, you need to know this. I would like to generalize in such a way. And obviously, if you are a DevOps engineer, performance engineer, right? You have to know all this. You have to know all this, right? And anyone QA engineer who is trying to migrate to automation or DevOps part, absolutely yes, you have to know this. And I would tell you why it is important. If you look at the next slide, where this DevOps, microservices, containers, and cloud fit, right? Where do this fit? Then you would understand why these are important. Look at this, right? I'm talking about DevOps, talking about microservices, talking about containers, talking about cloud. Look at this, where they are fitting. If you look at this slide and if you understand this, you would understand why these things are so important for everyone in IT right now. Back in 1980s, when the software development process started, we were all waterfall, right? The way we were developing was using the waterfall uh, model, but then we understood the disadvantages of waterfall, and we moved into agile, right? And where we took the development in phases. Here we did the entire development at once, and then we started to test. And it was so difficult for us to go back if we found any issues in testing, some major flaw in architecture. It was just not at all possible to go back and rectify things to make it better. That was one of the drawbacks of waterfall model, and that's where we shifted to a methodology where we did the sprint, the phase-wise development. We divided the same software into multiple phases, and we divided in the sprint wise. We call it sprint 1, sprint 2, sprint 3, sprint 4, and we did development, we did testing, then we went to the customer, we asked their feedback, we got the feedback from the customer, then again we started developing, incorporating the feedback of the customer, so that, and we were always in line with the customer. It was never a surprise for the customer what have we built, right? And that was the case with waterfall. So we were able to uh, uh, do much better in case of agile as compared to waterfall. And currently we are into DevOps, where we're talking about complete software SDLC automation. So we are further talking about the automation part, right? The SDLC automation we're talking about. Whatever we are doing in agile, the process wise it's still the same. Okay, the process wise we have not changed anything, but what we have done, we have automated things. DevOps is all about automation. If you attend any DevOps session, right, it's all about automation of right from the developer. When the developer is done developing the code and uploading the code to the GitHub, from that stage till we deploy the code to production, it's all about automation. In agile we are doing things manually, right? Like manual deployment of the product in the testing environment. Then some QA engineer would come and test the product manually. Then we'll deploy in production performance environment. Some performance engineer would go and test. Again, if everything looks good, we'll raise a bug. And it is very slow process. Agile is a very slow process, right? We never talk of continuous development. It's not happening in case of agile, and that's what we're trying to solve in DevOps. And most of the companies have understood the importance of DevOps, and what it brings to the table, the value it brings to the table by automation, and it saves such a significant time which can they spend on the product development, on the new build, new features, right? So that's why DevOps are so important, right? And that's where this DevOps fit exactly here. Again, so back in 1980s, when the software development was happening, it was all monolithic application. We were developing monolithic application. When I say monolithic application, I'm talking about the application server. Let's say I have a three-tier application here, three-tier application. I'm talking about the app server here. Let's say the middle one is the app server, and I'm writing, let's say I have 10 modules. So I'm calling the functions everywhere and everywhere, right? Anywhere and everywhere, I'm calling the functions, calling the modules. What it the problem was with the multi-application was that even if one of the module is having some issues or one of the functions is having some issues, it's gonna break the entire application down. That was the case in the case of monolith application, and that's where we are breaking down our monolith application to microservices, uh, and that's where this microservices come into picture, and it is much more reliable thing. Microservices here, let's say if I'm having multiple modules, I'm not going to call the functions. Let's say this is a module 1, microservices 1, this is module 2, which is running microservices 2. I'm not going to call the functions directly. There is no tight dependency. There is no tightly coupledness, loosely coupled. The microservices are loosely coupled. I'm not calling the functions directly, uh, right? I'm not. I'm if this microservices needs to talk to this microservices, I will expose the RESTful endpoint, and through that endpoint, I'm going to communicate, right? So consider the famous applications like Ola or Uber, right, or Swiggy that we guys use. All are based on microservices architecture. If I tell you that, let's say in Swiggy application, if notification thing is not working, one of the module is the notification. Whenever you book a cab or order a food in Swiggy, Ola, you get a notification that your food has been ordered or the book has been your cab has been booked, something like that, some notification. If I say that if a notification is not working, you cannot book a cab, it doesn't make any sense, right? Why? What has notification has to do with my core functionality? right? That was the drawback we had in the case of Monolith application. Uh, Even if one of the small bug could bring the entire application down, but it was not the case with microservices. Here, even if you have issue with one of the module, it is not going to directly impact the other module, and it gave us the high availability, right? The application was not down. Even if one of the microservices is not working, the entire application is not down here. We'll talk about each of these things in detail in the course. Okay, I'm just trying to give you a brief where this fit. Okay, if you're not able to follow completely, tightly coupled, loosely coupled, don't worry. Okay, just try to understand where this fit. Okay, earlier when we started, we were all monolith application, but now we're talking about microservices development. I hope you guys are who are working or taking up interviews, you know that people are developing microservices now. You guys are testing more into API, like all my performance testers, engineers friend, you know that you have been asked more of the API testing nowadays. People are not asking or doing more of a web UI, web-based performance testing tool. Mostly it's all API based. Mostly, I would say. I'm not sure, but I have seen this transition because I'm in this industry from quite some time. It's all about the API testing that we are doing as of now, right? Again, coming to the containers part, right? Again, when the software development was started, it was all into physical server. What we did, we used to install a tiny little application onto a big physical server. There used to be a big physical server, and we used to install a tiny little application like few KBs or MBs, and we used to waste a lot of resources back in 1980s. Then the virtualization came, and it was a rescue, right? And we were able to utilize the resource better. After the virtualization, we were able to create VMs, virtual machines. I hope you guys are working on virtual machines. It is only possible, you can only create VMs when you installed virtualization software like a hypervisor, or we have VMware, right? A lot of softwares are there, virtualization software, like in Oracle has VirtualBox, Windows have Hyper-V, like a lot of virtualization software are in the market. So if you install some sort of virtualization software, you can create VMs, and you can use one VM. In one VM, you're able to utilize resource better. In one VM, you can have your app server. In another VM, you can have your web server. In another VM, you can have your DB server up and running. Here, you are just having few KBs, MBs application in big physical server. We are wasting a lot of resource. Earlier, let's consider this as the 100 vCPUs, uh, vCPUs core, and let's say 100 GB RAM. We used to install some very KBs and MB application. We were wasting. After the virtualization, we could create we could create multiple VMs of different shapes and sizes, whatever we as per our requirement, and we could host multiple applications. It was a revolution. Still is virtualization, and in this way, we're able to optimize significantly on the cost part. We're able to significantly optimize the cost part. But nowadays, from last, I would say 2015, a company called Docker, one of the popular company, Docker, introduced something called Docker Inc. was the company name. They introduced something called container engine like Docker. Docker Inc., the company, introduced Docker, a container engine, and it revolutionized the way we deploy the microservices, the applications. In one VM, I can create multiple containers. That process is called containerization. And for that, we need a container engine like Docker. If I take one VM and if I install something like container engine like Docker, I can create multiple containers in one VM itself. What I'm saying, let's say if you needed three VMs to host your three-tier application, let's say app server, web server, database server. Now in one VM itself, you can have three containers. You can have three containers, one for the web server, one for the app server, one for the database server. What are we achieving here, guys? What are we achieving by doing this? Cost optimization. cost optimization is what drives the IT, right? If earlier you were, let's say, some company was spending $10,000, let's say that, per month on a billing. If this particular technology can reduce the cost by 40%, let's say now the company only needs to pay $6,000, right? It's a great deal per month, right? 4,000 savings just by changing the technology. Just from the virtualization, I may move to the containerization and I could save 40%. What else you want from the company, right? This is what containerization offers. The, the Docker engine like Docker, the container engine like Docker. And when we have a lot of containers, I need to orchestrate things. For that, I need a container orchestration engine like Kubernetes, right? We'll talk about all these things. So Kubernetes, Docker, we'll talk about in the container part. So it's a great move, right? So from here 1980s, we are here and we are here right now. That's why the entire world, entire IT is talking about container, Kubernetes, Docker, because they know the importance of Docker and Kubernetes. It's gonna do a cost saving for them, right? It's gonna save them big time, right? That's why they're talking about containers. It's not like they love the technology. No, they are able to save cost, right? That's what the cost optimization factor. Everyone is trying to optimize the cost. Even in our home, we do the cost optimization, right? In some way or the other. Same thing. Why not companies would do, right? Obviously. And that too, when they're getting more reliability, availability is more, reliability is more, they're getting more robustness. Why not? Why not to switch to Docker and Kubernetes, right? That's how these things have been, right? Going, right? Guys, it is making sense. I have been speaking from quite some time now, 10 minutes. I just want to wait. Guys, am I making sense to you? What are we discussing on this? Yes? No? Please use the chat option, guys. Okay, perfect. Good to know that you guys are with me. Okay, moving on. Okay, so earlier again, we had a data center. If okay, can you once let me know the again difference between VM and containers? Okay, Gayatri, I'll can you just recap? Just Siddharth, it will be difficult for me to recap things, right? Everything. Gayatri, no worries. Just I want everyone to understand the it's a high level information I'm going to give. I'm not. It is just a kind of a trailer of the entire course, right? Don't worry, Gayatri. I'll be talking a lot about this in a full course. Okay, if you have able to understand that is all because of the cost optimization and things like that, you're good, right? For now, okay. I think we need to move on. And if anyone wants to recap, I'll do that at the end. Okay. So for now, again, so back in 1980s, what is the option? If you have a great business idea, right? If you were Amazon.com, if you had this idea of Amazon.com or Walmart.com, right? You didn't have any other option but to come up with your own data center. You have to set up your own data center back then. And setting up a data center, it's a very costly affair. When I say data center, consider a building, multi-story building, 6 to 7 floors building. Consider 20-30 rooms, big rooms, hall like a hall, and consider all the rooms full of servers. Okay, imagine a setup that is called a data center. If anyone is just looking for what is a data center would look like, let me just show you what a data center would look. A center would look similar to this, guys. Let me just data center would look something like this. Consider a multi-story building and with full of servers like this. Okay, this is where your application is running, right? A data center. You didn't have any other option back then but to set up your data center. If you have a great business idea, right? But and it's a very costly affair. You have to purchase the land, start with the land acquisition, right? You have to purchase the land, you have to construct the infrastructure, these servers, you have to purchase all these servers, right? These servers will generate a lot of heat. You need to do cooling mechanism. You cannot let these servers go down for even for a minute. You will have to have multiple power backups, multiple redundant switches, internet service providers, multiple, because you cannot lose the connectivity, internet connectivity, you cannot lose the power, and a lot of those things. So setting up data center is a very costly affair. Very costly affair. Very costly affair. Look, I'm just seeing one of the things. Google unveils new $750 million data center as part of. Okay, look at this. Huge costly affair. Okay, huge. It's a very huge costly thing to set up a data center. Okay. Okay. So back then you didn't have any other option but to set up your own data center if you have a great business idea. Once you set up a data center, you can deploy your application for the world, and you don't know whether it's business going to run. You are not sure, right? You have done the data center setup, you have deployed your application, and you're not sure what would be the future of your application. You have just tried it out, right? So this was the scenario back in 1980s. Around 2000, a lot of companies came and who were providing the hosted. You can host, you can get the rent, you can host your application on their servers. There were few hosted service providers, there were few, but not many. But nowadays we are in the cloud phase, right? We're talking about AWS, we're talking about GCP, we're talking about Azure, we're talking about Oracle, IBM, Alibaba, DigitalOcean. There are so many cloud service providers. It just, if you have a business idea, it just about, if you need few servers, it just takes hardly 5 minutes to get the server and run your application. Hardly 1 hour to set it up, to create to create an AWS account, a GCP account, Azure account, right? And you can get as many servers the way you want, and much more functionality as what a data center would offer. That too, you don't have to invest so much. You can pay monthly. You can pay monthly. It's not like one-time effort. There you have to set it up. You have to invest so much to deploy your application. You can just pay a few $100, right? Monthly, you can test whether your application is good. People are trying, getting traction, and then you can scale it up. You can have your own data center, things like that later point of time. But to get started, no one would stop you. That's why you see so many startups nowadays, right? If anyone has some business idea, they would go to any cloud service provider, and they will have some infrastructure, and they will deploy that application. As simple as that, right? So this is where we are in, right? So when I asked you this question to get started, that do we need to learn DevOps, microservices, containers, and cloud? Now tell me one thing: those who did not have any option. So tell me, what to learn? This is the current thing. The way we are developing, uh, it is all the part of the current IT infrastructure right now. DevOps is the culture that we are into. Everyone wants to automate things. Whether you are a soft QA engineer, DevOps engineer, performance engineer, developer, you will have to do automation at your end, right? There will be a full-fledged DevOps engineer who would do a CI/CD pipeline. That's another thing, right? But everyone is expected to know CI/CD pipeline and how do we work, how do we use tools like Jenkins as a CI tool and integrate things like Maven, Git, Ansible, Terraform. Everyone needs to know about all those things. Microservices, that's how we are. We are no more developing monolith application. It's all about microservices. We have understood the importance of high availability and what it brings to the table, microservices. And where do we host these microservices? Guys, any idea where do we host these microservices? Look at this. Do you see any connection between these two? Where do we host microservices? Where should we host these microservices, guys? On the containers. On the containers. Right. We have split this up. And we have split this also. We have split monolithic, made it microservices. We have split VMs and we have made it to containers. The microservices goes perfectly well with containers now. This is where the containers are. We deploy microservices on the containers. And this is what. And when we talk about microservices, we are talking about for each of the microservices, we'll have a separate CI/CD pipeline, a separate SDLC, so separate software development lifecycle. Will build separately, will deploy separately each microservices. It's not like we have to wait for the entire application to be hosted and deployed. Nothing like that. If this microservices is in a better shape, I can deploy this independently. I don't need to wait for other microservices to combine and then test it. Nothing like that. I can deploy this. I can have a separate SDLC for this microservices. For each of these microservices, I can have a separate SDLC, and I can make use of DevOps to automate things. Right? Where do we create these VMs, and where do we do all these things? In the cloud. Guys, able to understand how these things are related? There's no other option. You have to learn all these things, right? Whatever you are, start on these things. That's where you're gonna be in IT. That's how you're gonna be relevant. That's how you're gonna be excelling in IT. That's how it is, right? Yeah, I cannot stress that enough now. That absolutely and absolutely, you need to know all this, whatever profession you are in IT, right? Yeah. So coming to this course, right? Okay, before I go to the course, any question I can answer for you guys? You can unmute yourself. I don't mind.
Hi,
Yeah.
hi, Roshan. Hi, Roshan.
Yeah, hi.
Hi. See, as I see the things, so you're mentioning the word, so performance engineers should be coming into SRE, DevOps people should be coming into SRE, and the architects are coming into SRE, even developers also coming into SRE. So
That's right. They have.
hello.
Yeah, that's right. Please, I'm able to hear you.
Yeah, see, the thing is, right, see, yeah, in the SRE roles also is like more like a conceptual. So in each company, so team are doing a different tasks for SRE role, as a SRE role. So,
Yeah.
so are we going to combine all these SRE tasks because each client is asking them to do any different roles and responsibilities based on their application business and model and all, right? So in this course, so because I'm completely from performance testing, I don't know anything about DevOps. So before becoming a SRE, I should be thorough knowledge in DevOps.
See, when you say you don't know DevOps, right? So when you say performance testing, so are you into just using performance testing tool and doing troubleshooting performance issues?
Yeah, so I'm doing mostly like using a Jmeter with the other monitoring tools, which is deployed in AWS.
Yeah.
And doing testing. On top of it, we are doing some kind of a chaos testing. So in my client, so not doing actually the pipeline integrations or any kind of a core SRE activities.
See, it all depends, your aspirations, Sridhar. What do you want to become, and how do you want to see yourself in your career 5 years down the line? It all depends on your aspirations. If you want to do the same thing what you're doing, you can do that. Continue doing that. But the way IT is moving, right? Uh, as a performance tester engineer, also people are doing automation. I hope you're aware of it, right? Uh,
Right.
Automation of some of the other kind. Either they are doing some sort of shell scripting to to do a monitoring. So you write some shell script to collect all the CPU, memory, disk information. Write a shell script and collect all the results for the test duration. If they don't have any commercial tools, see, automation is for everyone. Either you are a QA engineer, DevOps engineer, performance engineer, developer is doing automation only, right? So it's all about doing that, right? And when I talk about microservices, so whatever testing you are doing, the application is microservices based, correct?
Right.
Right. So and you told you're working in cloud, AWS, right? So
Right.
just combining all these things and giving you a holistic view. That is what this course would do.
Okay. Yeah. So my main question is here, the SRE, right? The
Okay,
SRE roles and
I'll come
response.
to that. Sridhar, I'll come to that. When I say you have any questions, do you have any questions on DevOps, microservices, containers, or cloud? I'll come to SRE and performance engineering in some time. Okay, do
Okay.
any specific question in whatever we have discussed so far? I wanted to answer that first before going into SRE and performance engineering differences and all that. I'll come to that, Sridhar, in some time.
Okay. Yeah. Thank you so much. No problem.
Sure. Okay. Any question on this part, guys? If anyone is not clear what is DevOps, microservices, containers, cloud, anyone has no clue, uh, please feel free. I can help you in some way or the other. Okay. So I take silence that we are all good. Okay. I'll assume that silence we are good, guys. So let's come to the
Hello.
yeah. Yes. Yes, Ravindra.
Yeah, actually, are you covering Docker, Kubernetes, all this stuff, DevOps in detail in
That's
this
right.
course, or
That's right. I'll come to the
you will?
syllabus, but we are covering, yes.
Okay, okay.
In just few minutes, guys, I'll directly go to the course syllabus and what are we covering. I'm going to talk about it. Okay, so this particular course, right, what I have done, I have combined two courses. Okay, from a performance engineer point of view, those people who are from performance engineering background, those who are doing performance testing, right, and doing engineering work, for them, they need the cloud microservices knowledge. Not They are not looking to become an SRE. For them, see, the 70% of the course, 65% of the course is going to be the same. Okay, what I'll be talking more. Okay, so let's talk about this 65% of the course. Okay, I'm talking about cloud performance engineering in DevOps. What are we covering in performance engineering course? Then I'll talk about what additional we have in SRE. I'll talk about it. So as part of cloud performance engineering course, we have these modules. We're talking about cloud computing. We'll talk about AWS. And guys, when I say I'm talking about from scratch, I'm not expecting you to know anything about cloud. I just expect you to know, have a basic understanding of IT. If I say IP, address, port, right? I want you to VM. I want you to understand that. That's all the prerequisite is required, nothing else. So I'll talk about cloud computing here, because I understand. See, I talked about four things, right? Four things. I'm covering all those four things here. That's all. Simple. Cloud computing, AWS. If you guys don't know how to work on AWS, how to create EC2 instance, what is a network, right? If you don't know what is a database service, right? All those things, right? What is auto scaling? What is load balancing, right? All those things we're going to talk about. We have monitoring solution also, CloudWatch. So if you're not sure about anything about AWS, new to that, we're going to take up these things first. AWS. For anything to work, apart from if you want to work on microservices, Docker, containers, whatever you want to work on, Linux knowledge is must. Okay, so we are providing this as the self-paced course. Linux. It's going to be my videos. I have made it, right. It's going to be self-paced videos, some 3 hours of content, and we're talking about Linux command line and shell scripting as well. Okay, because it is mandatory thing. Okay, you need to know this because it's all about microservices. It's all about Linux. Microservices. When I say Docker container, it is supported on Linux operating system, not on Windows. Okay, so that's why understanding of Linux operating system is Linux command line is must. So as part of that, I'm covering that Linux command line. It's going to be self-paced. The moment you're going to enroll to the course, you'll be given this access, and you're supposed to cover those 3 hours. And you can ask me any time questions. Next time when we meet for the session, you can ask any doubt, whatever confusion you have. You will have all those luxuries, the opportunities to ask me that you could not understand this. I'm gonna explain that. Okay, so it's not like I've given the self-paced, you take care, nothing like that. I've given the self-paced so that I can focus on something else, right? So that is the intention here. Moving on, I'll talk about the architecture point of view. As I told you, right, we're talking about what is monolithic application, what is microservices. We'll talk about the architecture point of view. These things will make it clear what is monolithic, what is microservices, how they are different, what is the advantages of monolithic, what is the advantage of microservices, those things. We'll talk about Docker, because what is Docker, first of all, what is container engine, what is the importance of Docker, why do we need a Docker? We need Docker to create containers, right? We'll talk about it, everything from scratch. Okay, what is Docker? Why do we have it first? How do we create containers using Dockers, right? And then once we have that understood the Docker, when we have a lot of containers, you need to orchestrate things. So I'm going to talk about container orchestration engine later after Docker. That's called Kubernetes. We'll talk about that. What is Kubernetes and things like that. Everything about Kubernetes, architecture, how do you deploy application. Kubernetes is a very important concept. It needs some understanding. It's from very basics. I'm going to cover things. All I need is your enthusiasm and the willingness to learn new things. And I can promise you that you will learn things. Okay. We'll talk about Kubernetes, and then we'll talk about DevOps. So you can see whatever the 4 things that I promised, I just showed you. We are covering everything in this Cloud PE course, right? Everything. And then for the performance engineers, testers, right? How do you integrate performance testing in CI/CD pipeline? You need to create a job, performance testing job, right? And how do you contribute to the CI/CD pipeline, which is at the organization level? So this is going to be the course syllabus for the Cloud PE course. Okay. So that is what the Cloud PE course would offer. Okay. I'll go in detail about this. Any question on this slide?
Yes, Roshan,
Sure.
Prem here. So I have a couple of questions related to almost all the topics. So I'm hoping that we'll get to do some practical as well as far as AWS is concerned. Like account will be created and then will be assigned with practical task and all. Is it there?
Absolutely, absolutely, right. You see here, it's hands-on. I'm gonna do it, and you supposed to practice it later. Everything, whatever we are going to discuss, you're supposed to repeat at every session. I cannot let you do along with me. That option is not there because we are meeting only for the 1 hour on daily basis. So that option,
yeah, fair enough.
Right? But it's a hands-on. I'll be doing it, and you're supposed to practice everything on your own, in your own account. Yes.
Okay. And regarding third point, that is software application architecture. So I know you will be covering almost types of the server we had, server architecture. But are we also going to cover basic servers architecture details, like how .var file, how .jar file works actually, like JBoss and
those
all those.
application servers. I'll talk mostly here when I say I'll talk mostly about microservices. What is microservices and what is monolithic, and what is the difference between microservices and monolithic? Jar file deployment, Tomcat server, simple stuff, right? I'll talk from an architectural point of view, not how do you build using Maven. That comes under DevOps course. How do you build jar file using Maven, like that? That is a typical DevOps course. Would that be right?
Okay.
Here I'll talk about microservices. What is microservices? I'll make your understanding clear and how it is different from monolithic.
Okay, fine. Okay, and regarding point 5th and 6th, so here, like again, it may comes into DevOps, but again, are we also go through the process to create image and all those stuff and deploy servers?
When I say DevOps, it is not like we are not covering here. We are covering everything what we covering in DevOps. What is expected in DevOps, we are covering everything here. Because either you are a DevOps engineer or a performance engineer, you need to know this. I have been interviewing people like performance engineer people. They tell I'm working on container. When I say how do you create it, they don't have any clue, right? They are working
Right.
on container, but when I ask, they should know, right? How do you create it, right? How do you run it? How container different from VM? They don't have any clue when I ask them. So we need to make that understanding clear. What is VM? What is container? How do we create container? What is image? What is Docker lifecycle? What is volumes? Right? Different things. We'll talk about each and everything there.
Okay. And last one, like performance engineering, what kind of topics we will be covering?
So we'll just
under
understand
performance
the roles and responsibility here, nothing else. Roles.
Okay, not like conventional performance issues
No,
troubleshooting.
conventional we are not talking here. Java performance engineering,
Okay.
heap dump, thread dump, and
Okay.
SQL tuning. We are not talking here. This course is not for the conventional performance engineering. It's mostly from the infrastructure point of view. We are not talking about application performance engineering here. We are talking about infrastructure performance engineering here.
Okay, that's fine. Thanks, Roshan. Clear to me.
Sure. So this is the course syllabus, guys. Anyone have any question on this point?
Yeah, hi Roshan. So one question regarding cloud computing AWS, right? How depth will be covering AWS?
So your answer is,
it,
here. Your answer is here. Okay. We'll talk about these things.
Okay.
We'll make sure how depth. You cannot define a depth, but what I'm going to promise you that you'll be comfortable working in cloud, talking to any DevOps professional in your organization, talking to anyone in your organization, you'll be comfortable. That's what I can promise you. Yeah.
And will it cover like for solution architect associate certificate?
See, we are not talking about. See, we are almost there. I would say 60% we are covering, but it is not a certification point of view training. Okay, this particular training is for the performance tester or QA engineer, DevOps engineer, what they need to know. So yes, you're gonna be 60% there, but you need to put extra efforts to clear the certification, and that I can guide you.
Okay, thank you, Roshan.
So all these are topics. Okay, I don't want to go on each other topics. People may feel overwhelmed, right? But if you are able to understand few folks, you can go on this topic that we're going to discuss. Okay, so that's about the cloud computing. That's about the Linux from basics. Everything is from scratch. This is gonna be the self-paced. I'm gonna again telling you this is gonna be self-paced. I'm gonna give you videos, my videos, and you can ask me any doubts. And it's from very scratch. I'm gonna share the PPT as well, right? And for everything, right, you'll be given a PPT, guys. Let me just show you how it would look, right? I'm gonna give you these kind of PPTs for every batch that I take, right? I share these PPTs like April batch you have, right? Look at this, all the PPTs I have shared. Okay, let me just, so I'm going to share all these for every cloud computing or Linux command line or Docker engine or container engine or Kubernetes. Every one PPTs would be there. So if you look at the cloud computing that we are discussing, it would be like 200 pages PPTs that we're discussing here, talking about here, right? It's quite in detail we're talking about. You'll be comfortable. So you can just look at the number of PPTs here, slides. It's going to be quite, let me just, yeah, for these Kubernetes and these are two the biggest one, 174, okay. And Kubernetes is like 100, 120. Because those are the biggest two topics that we talk about, cloud computing and Kubernetes. Is going to be container orchestration engine, right? Kubernetes, everything is hands-on. I'm going to take EKS as the example, EKS or GK, Google Kubernetes Engine, right? Anything. I'll mostly prefer EKS. We can also go with GK, Google Kubernetes Engine. I'll talk about what are those things, right? It is the one of the 114 to 20 slides. Yeah. So yeah, those two are, and we're gonna share all these things so that for you to refer, revise things. I'm gonna share a lot of um, YAML files on the Kubernetes, like a lot of YAML files, load balancer surveys, node port, like a lot of things I'm going to share with you. Okay, so that's about Linux thing. Okay, then we'll talk about architecture point of view. What is microservices? What is monolithic? How it is different? We'll talk about these things. We'll talk about Docker development, Docker lifecycle, Docker Compose, what is Docker volume. From a performance engineering point of view, we'll talk about how do we check Docker logs, right? How do you make sure that one container will have this much CPU only, right? Because in one VM, we can create multiple containers. We'll talk about how can you allocate one specific CPU to one container. We'll talk about those things in Docker Engine. We'll talk about performance engineering and DevOps. What are the roles and responsibility? How performance engineering fits in DevOps. We'll talk about that. And Kubernetes, a lot of these things, automatic scaling, horizontal pod autoscaler, cluster autoscaler, a lot of things, architecture and a lot of things. We'll talk about it. Then DevOps, CI/CD pipeline. How do you create your own Jmeter job? This is one of the, from the class I've taken this screenshot. This is a job we're going to create, a Jmeter job and things like that, right? So this is going to be the performance engineering course, right? Coming to the site reliability course, okay, let me just talk about it. So you can find this course here, guys. I'm going to give you the link. You can go on your own as well. And I'm going to talk about it. What is extra that we are going to talk about in the SRE, right? So this is what I talked about performance engineering course. You can enroll this as well. And SRE will have something more. Okay, if you're looking to join an SRE, you will have something more. Okay, this is the I have shared this link, guys. You can go over on your own. The other thing that we have is the SRE, okay, site reliability engineer. What are we adding extra from the SRE point of view? Let me go over it. Okay. So we are going to, whatever we have discussed in the cloud PE, we'll have that. Okay. Apart from that, we are going to, for the SRE, the development is important. Okay, Java and Python. So what are we doing? We are going to give you self-paced Java and Python along with shell scripting, which I talked about it. You're gonna get 30 hours of Python self-paced videos, because for the SRE, development is also important. You need to be a developer as well. Being an SRE, you may be asked to work. Someone was mentioning SRE has multiple roles and responsibility. It all depends on the organization. Yes, I do understand. In most of the organization, when I say SRE, people are expected to develop also. So for a performance engineer, those who want to change their career and being to SRE, they need to have some sort of programming language as well, and nothing like it Python. So that's why we are giving 30 plus hours of self-paced videos on Python from very scratch. We are covering, and along with that, we are also giving Java, core Java. Here we'll talk about installation of Tomcat, deployment of Java application. Someone was asking jar file, war file. We'll talk about threading, and like you can consider like this is going to help you in the Java performance engineering concept, the core Java. So we are going to give these two things extra, Python and Java. Apart from that, what is more important being SRE is the automation. Okay, so we're going to talk about automation here, infrastructure automation using Terraform. We'll talk about, because one of the roles and responsibility of an SRE to eliminate the toil and automation. We're going to talk about that. We can talk about infrastructure automation using Terraform, a configuration management using Ansible, CI/CD pipeline using Jenkins, and automating mundane tasks using shell scripting and Python scripting. This is what we're going to discuss on the SRE part. And we're going to also talk about some traditional performance engineering concepts like database performance, Java performance tuning. I'll talk about it, thread dump, heap dump, because as an SRE, you need to be also as a work as a performance engineering, right? You need to also understand database performance, what all different aspects, what is SQL tuning. We'll not go in detail. Let's not think like we're going to cover 40 hours. I can make 40 hours in this only, but we'll try to give from an SRE point of view, because SRE has many roles and responsibility, and one of the roles and responsibility is to understand, run some Jmeter tests and do some Linux performance using some top command. How do you or we have vmstat command, mpstat command, what is load average. We'll talk about these things. We'll talk about Java performance tuning. When I say talking about the heap dump and thread dump, when to take heap dump, when to take thread dump, how to go about analyzing things, right? Database performance, we'll talk about it. Depends on all the databases. You will take it from the cloud point of view. What is read replicas, right? And this normal SQL tuning and those things, we'll talk about it. And one of the very important thing is that observability. These things are additional in the SRE course, which is not there in the cloud PE course. Okay, observability, we'll talk about it. Linux monitoring, CloudWatch, Prometheus and Grafana. We'll talk about what is Prometheus and Grafana, and we'll talk about ELK stack as well. And not just that, alerting is also important, because as an SRE, you need to also do the alerting. Monitoring is one thing, because as an SRE, one of the roles and responsibility for you to work on production. Till performance engineering, you are performance engineer, you are not exposed to production. But one of the roles and responsibility of SRE is to work in production, and you feel things, to look into the issues, and you need to do alerting also. You need to do proactive alerting, because if let's say thread issue is there or memory issue is there, out of memory is coming, you need to get alerted well in advance, so that before a customer complains, you get to rectify the issue, you get to solve the issue, right? So proper alerting is very important, and we'll do it using Grafana. How do you do alerting, right? So all these things, and ELK log analysis, we'll talk about it, because in production you need to analyze the logs to understand the root cause, right? This is the observability, we'll talk about it, right? And this is how we're gonna work on resilient. One of the core responsibility of an SRE is to make your system highly available and resilient, right? So how do you make use of RDS and DynamoDB? They are the AWS databases, we'll talk about it. How do you do a fault tolerance using Lambda and EC2, right? We'll talk about it. Load balancing and auto scaling. These things are there in Cloud PE course as well, right? But we'll talk about from the reliability point of view in SRE course, right? So these things are extra in SRE. Guys, am I making sense to you? What is extra and what is... So as I mentioned, 65 to 70% of the course is going to be same. But when it comes to SRE, your roles and responsibility would vary. You're going to be working on production environment. As a performance engineer, you don't work in production environment. You work on the development or performance engineering environment, performance environment. In SRE, you work in a production environment. And that's where this roles and responsibility is added advantage. That's right, Parag. I'm going to set up Prometheus and Grafana and doing alerting as well. Yes, I'm going to show you using Helm chart. Okay, guys, so let me give...
Hi, Roshan.
Yeah, go ahead.
One query. Will you be discussing on Azure?
See, again, I cannot discuss on Azure as well, right? I'm talking about AWS here. I can talk about GCP if someone is interested. In Azure, I don't see we'll be running out of time. This course is a very exhaustive course. Before you enroll, make up your mind that we're gonna meet daily for 2.5 months. If you put Azure, it's gonna be complicate things. But having said this, right, know one thing: if you know one cloud service provider, anyone, you can learn other. May I know who asked this question? Just from, I'm gonna give you one example. And your background, please.
Mega.
Mega?
Performance test engineer.
Performance test engineer. Okay. I'll tell you. If you, which performance testing tool you have worked on or working on?
Jmeter.
Jmeter. Any other performance testing tool you have worked on?
Yes, LoadRunner.
Perfect. So if you have worked on LoadRunner, right, and how do you feel working in Jmeter after that? It's all about getting comfort, right? The concept-wise, the correlation, dynamic correlation, parameterization, looping concepts, almost those things are same, right? Everything is same. Only thing, the way we do is different. The UI is different, right? That's the only difference between the one cloud provider and the other. The UI would be different. I'm going to show you how to take things up, right? I know all the three, okay? I know all the three cloud provider. It's not like I have learned, someone has taught me this, nothing like that, okay? I knew only one cloud provider to start with, AWS, and I've learned AWS and Google from my side, like from my end, because all are same. It doesn't make any difference to me. Only the UI part is different. I'll tell you how. Okay? I'm launching this AWS here. If I need a service server, I'll go to EC2. EC2, I know EC2 is the service that I need to go in AWS to get the server. I go to EC2 and I can provision some servers. Okay. In GCP, if I talk about it, I know the same EC2, they're calling it compute engine. I know this, they're calling it. So this is the GCP, guys, Google Cloud Platform. I know that the same. Okay, let me do one thing. Let me just connect it. Let me select the project. I'm trying to give you a broader perspective how to understand how to take up things. Okay, just learn one cloud service provider. It could be anything. You can start with Azure if you want. Perfectly fine. I'm not favoring one over the other. No, okay. Don't get me wrong. I'm not favoring one over the other. Okay. I'm just telling start with one, and you can easily learn others. That's what I'm telling you. Okay. So look at this. I went to EC2 in AWS. If I have to working in GCP, I'll go with compute here, compute engine. That's all. The UI part, the look and feel is change, right? That's all it is. But I know where to get the VM instance or VM machines. I can just go to virtual machine and I can get the VMs, right? It is as simple as that. In Azure, they call it virtual machines, right? That's how VM instances, I can get the servers, right? I'm going to give you one link that's called comparecloud.in. That is the best link anyone can give you, right? Um, um, so if you know one cloud provider, let's say you know AWS, you can understand what the relevant cloud service provider in Azure and GCP or IBM, Oracle, Alibaba, Huawei, whatever. Let's say EC2. Amazon EC2 is the AWS service for the virtual machines. If you need a VM, you go to Amazon EC2 and get a service. If in Azure, go to Azure virtual machine. If you are in Google Cloud, go to Compute Engine. Same thing, right? Same stuff. If you are using Lambda in AWS, you use Azure functions in Azure and you use Google Cloud Functions in GCP. That's all. The UI part would be different, but the core functionality remains the same. So to answer your question, I'm not going to cover Azure, but I'm going to talk about in such a way that you can learn other cloud provider. Could be GCP or Azure in your own way, right? Yeah.
Okay.
Let me give you this link, guys. You can just keep this link handy with you. This link would help you getting knowledge with multiple cloud service providers. If you're like interested like me, because I'm interested to learn others. If you know, if I explore one thing in one cloud, I just immediately go to other cloud provider and explore on my own. That's how you learn things. Similar. Okay. Anything else, guys? I can help you with any information you're looking. I have given you these two links, right? Cloud PE course and site reliability engineer course. I've given you both the links. You can go and you can decide We'll get started. Tomorrow we are going to meet anyway. First day. Yeah. Okay. Any more questions, guys? I can help anyone with. Anyone has any question?
What was the course duration? You mentioned, you did mention that.
I have mentioned it. For site reliability engineer is going to be 50 hours. Okay. I have asked them to mention it. Let me check it. If they have not mentioned it, it's going to be 50 hours. Yeah, 50 hours they mentioned it.
Okay. And how about Cloud P?
Yeah, 40 hours. 40 hours. Yeah.
Once the audience link is finalized, then you will share the Python videos links.
Yeah, once the course, once you're enrolled, you are gonna get self-scripting Java Python videos first, and then we'll start with the course. Meanwhile, you can start working. So make it a plan that you're gonna be your next 2 to 3 months gonna be very hectic. You're gonna be good a lot of learning. That would be the thought process before you enroll to the course. Yeah.
Roshan, the SRE and the cloud performance engineer, it's a separate course or like it's a combined one? Like SRE is a plus.
It's gonna be two different courses. Some people may opt for Cloud P, some people may opt for SRE. Clear demarcation, I just talked about it. If you are joining Cloud P, you are not going to get Java and Python, right? You don't need to, right? And you don't need to learn all the automation stuff or the things that we do in production. You don't need to know if you're doing Cloud P course, but from the SRE, you need to know the automation and all those production alerting thing as well. So only as I told you, 70% course is the same. 30% is what extra, and they will not be. We will have a separate topics, separate meetings for that. We will maintain two groups.
Roshan, this is Sridhar again. So suppose if I want to know the topics around SRE and the reliability, resiliency, observability, right? So can we have any other session, or are we going to combine in the same batch?
See, don't worry about it. Okay, if you are looking for SRE, you will get everything on SRE. If you're looking for Cloud P, you get everything on Cloud P.
Okay, because earlier itself I already learned from you. It's the AWS cloud and
you
all.
have learned already from me. Okay, then what you do?
Yeah.
You do one thing. If you have already joined this course, right? You can just enroll and you can get this. You can talk to Mr. Kumar. I think through Kumar only you have enrolled, right?
Okay. Yes, yeah, I know, yeah.
Right.
Yeah.
Talk to Mr. Kumar. He would guide you. He would guide you how to proceed on this. Yeah.
Okay. Yeah, thank you.
For those who have already joined Cloud PE course, we have some special discount for them. Yeah.
Roshan, Gayatri here.
Yeah, hi Gayatri.
Hi guys. Hi. I have one question. For people like me, around 6 to 7 years in performance engineering, where I mostly worked on web applications, the conventional one which you were talking the entire and everything. So, how do you think the cloud performance engineering, like from the infrastructure perspective, would help me? I mean, how would my career be helpful with this course?
See, if you are looking for eventually you would need to learn. Okay, either you are a performance tester or performance engineering. You're starting. If you want to learn traditional performance engineering, I would not say if you're trying to learn full-fledged. Though we have some sections, right, for the performance engineering, right? We cover 2 to 3 hours, right? Mostly 4 hours. We'll cover this here, right? But this is going to help you, right? The container part.
That's correct. I'm talking from the perspective where we don't have much visibility or access to the environments, the complete environments, right? That is where my question is. So how do you think it would help me?
If you don't have a visibility, switch the company.
Okay.
Because you are not in the right track. I would say that. Switch the company. You are working on some traditional company who is not into cloud, DevOps, and those things, right? So I would suggest, if I would be in your shoes, I would be in a company which is having these technologies, because this is going to be the future, right? That's this still the present, right? I would try to think that way. Yeah.
The Roshan timing will be same for SRE and the cloud pay, right?
Right. Yeah.
Okay. And I'm the QA engineer plus 6 years experience. So like after completion of SRE, so I'm able to switch or like to change my career path into the SRE, right?
This course is going to be a catalyst. Okay. This course, I don't promise a job switch. Cannot do that, right? It all depends on your interest and your things. But if you look at what I'm going to tell you, go to LinkedIn, go to Naukri, okay, go to job section, try to look for SRE and what we are covering and what they are offering, what they are. You will get a better understanding where what you want to be, what type of job you would get. I would ask you to do this research. I have done my part.
Okay.
In putting the course together, but you should do your part as well. What they're asking and what we are covering, and then you would get a better understanding. I can comment you anything. Yes, I'll get a job, but nothing like that, right? You will have to work on your own. Yeah. So do this research. Go to these things. Look at read this, what they're expecting. Read through 20 profiles and look what we are covering, and then you take a decision.
Okay.
Yeah. Right. Fair enough. I hope I'm making sense. Yes. Yeah, perfect. Yeah. Just go over these things. Okay. Just search. You would understand what they're expecting. Everywhere you would find what we are covering.
We have different, prospects about this SRE across the industries. That's what we discussed last time also in the demo. And then the guy who asked this question, right, trying to help him. So when you're trying to apply for any job with SRE role, you need to make sure whether are these roles and responsibility I'm fit or not. Because simply you cannot go into a support guy or an incident management guy or a developer who has SRE responsibilities. We cannot go and fit there. Might be if you have development knowledge, you can fit, but where performance tuning or engineering on cloud knowledge is required, after this course, probably we can go and fit into that, whatever it suits better. So that's where Roshan was also telling last time. So we need to look into this. It's not simple saying SRE is a performance testing or engineering. It is across industries, multiple flavors it has.
And I have tried to come up with a generic expectation, right? Through this course, I have tried to outline a generic expectation. If you attend this course, definitely you can clear the interview. No doubt about it, right? I don't have, if you just follow religiously, right? If you practice everything that we are covering, if you do that, nothing can stop you in getting all the job. So just, I would ask everyone, go to these job profiles and look at the course curriculum. You would understand the way I have planned it. Doesn't make any sense, right? Coming with a course which is not in line with the current expectation, right? So I have tried my best and put my all the experience to come up with a generic course. Coming up with a generic course on SRE itself is a something, right? Because such a different roles and responsibility across organization, right? So yeah, be rest assured, yeah, you will be, in safe hands. Okay, I can just say that. Okay, any more questions, guys? Okay, sounds good. Silence means we're all good. So thank you everyone for connecting. We'll meet tomorrow. Okay, same time at 9 o'clock, 9 p.m. IST. Keep in touch in the WhatsApp group. You have my contact number as well. Let me know for any questions. If I can answer you in any way, I'll be glad to help you. Thank you guys. We'll meet tomorrow. Thank you.